Welcome to the podcast. We're just going to pick right up where we left off at the last podcast. The last podcast talked about electrons and where they live. We want to get into that a little bit deeper, not just in the energy level and where the electrons live, but we want to know the exact place where you can find an electron. But we can do a better job than what we've talked about, than saying the first energy level or the second. We can actually define a little bit better where an electron lives. And if we know where it lives and how it behaves, then we can have a better idea of how things will react. How will one element react with another? Will it be something that wants to take electrons, something that wants to give electrons away? That's what we're after here. So you guys need to get this stuff in your notes. This is pretty straightforward out of your book. The way we're going to treat this is like an address. If you wanted to address a letter, you would start with the idea of what is the zip code? That's the most general piece of information. Madison is 35758. Now, within that zip code, you can have a bunch of streets, right? So the next most general piece of information is the street name. On a street in a zip code, you can have a bunch of houses, and then you can have the person's name. So let's say you lived at Bob Jones High School. That would be weird, but let's say you lived there. The zip code, 35758. The street name, Hughes. The house number, 650. That's the address of Bob Jones. And your name here, Joe, Susie, Frank, Mufasa, whatever. And the idea here is that if you know very general pieces of information, and if you know very exact piece of information, you can address any letter. By the same token, we're going to say the principal quantum number is like the zip code. It is the energy level that you find the electron. That's a very general piece of information. Angular momentum says in that energy level, what does the orbital look like? What shape is it? We have several different shapes to choose from. Hang on. If this is a level, then this is a sublevel. Within a given sublevel, you can talk about the orbitals. Okay, there can be many orbitals in a sublevel, many sublevels in an energy level. And then the last one is what we call the spin quantum number, which is the identity of an electron. In any orbital up here, there are two electrons. It's like saying in any house, there's two people. If one spins up, the other one spins down. So if we know whether it spins up or down, its orbital, its sublevel, and its level, then we can do a good job of describing where the electron lives. So you just need to get these in your notes so that we can practice them in class a little bit. I don't expect you to actually be able to do this right now, but we'll practice it in class. This will make things faster and easier. We have many different shapes. So these are the sublevels. I'm going to give you 4 sublevels. The first one is the S sublevel. The S sublevel is spherical. It is a very small sublevel. Now you can have this sublevel on the first energy level, on the second energy level, on the third energy level. You can have it on any energy level. But S street or S sublevel only has room for one orbital. So on S street, write this in your notes, it only holds 2 electrons. One orbital, 2 electrons. That's S street. The next one is called P street or the P sublevel. The P sublevel actually has enough room for 6 electrons. So you notice 3 shapes here. They're the same shape, but one lies on the x-axis, one on the y, and one on the z. Each one of those shapes holds 2 electrons, just so you don't get confused. If I come down here, this whole shape is where 2 electrons live. They can live anywhere in that cloud right there. If they live anywhere in that cloud, and we can say that's a space where 2 electrons will live. So within the P sublevel, there are 3 orbitals, 1, 2, and 3. Each orbital holds 2 electrons for a total of 6. P sublevel, 3 orbitals, 6 electrons. This is the D sublevel. The D sublevel has 5 orbital possibilities. Again, these are clouds where you might find an electron. Somewhere in these shapes right here live 2 electrons. That one looks like a baby pacifier. The rest of them, if you notice, the rest of them are arranged so that they don't really get in each other's way. If you combine all of these together, they would pretty much fill the area. The D sublevel has 5 orbitals and 10 electrons. So let's see if you're following along at home. S holds 1 orbital. P holds 3 orbitals. D holds 5 orbitals. Guess what the next one's going to hold? 1, 3, 5. Sounds a little odd, doesn't it? You can laugh at home now. 1, 3, 5. The last one is 7. So 7 different orbitals for 14 electrons. Hopefully you don't actually write this in your notes. If you do, I want you to give yourself a little bit of slap in the face because you should know better. 7 shapes, 14 electrons. This is what F looks like. I'm not going to expect you to draw these or know all these crazy things, but that's what we think the F orbitals look like, all 7 of them. In order to know where they live and how they go, you guys only need to know 3 rules. And after these 3 rules, I'm going to stop, and then we'll practice in class. This is called the off-bow principle. Electrons have to go from the lowest energy level to the highest. The lowest energy level is the first energy level. The 7th energy level is the highest energy level. All you have to do is get this diagram, but all you need is this diagram in your notes, and I'll show you how to use it in class. But basically, you're going to slide down these arrows. So the first thing we're going to go to is the 1s, meaning within the first energy level, the S sublevel. And then we'll go up here and slide down. Whee! And when you slide down, you'll fill up the 2s. And then you'll fill up the 2p, the second energy level, the p sublevel. And then you'll go to 3s and 3p and 4s and 3d. I know it seems like we're going out of order, but that's the order that we actually find exists, going from low energy level to high energy level. So that's the order we have to follow, and this is called the off-bow principle. The other 2 rules are simple. I'm not going to demonstrate it for you because I'm not on camera right now, but in fact, I don't think I'll even show you in class. I used to do this dance thing, but I'm getting too old. Every orbital gets 1 electron. So let's say you're in the p sublevel, 3 orbitals. Every orbital gets 1 electron, and then if there are enough left over, then everybody can have more. Then everybody can have seconds. Same thing as what you do at dinner. The Pauli exclusion principle is simple. Your book doesn't make it sound like that, but the Pauli exclusion principle basically says if 1 electron spins up, the other one spins down. If you know those 3 rules, Hund's rule, the off-bow principle, and the Pauli exclusion principle, you can do electron configurations. And in class, when I see you, I have a surprise for you because I'm going to be able to tell you something cool about the periodic table. I don't want to give it away just yet, but it's coming up. See ya!